Today I want to talk about artificial intelligence. Let's have a look at a comprehensive journey into the future. The dawn of AI, from Turing to today. 1950s. Turing's vision. Alan Turing, in 1950 paper Computing Machinery and Intelligence systematically discussed the possibility of machines thinking. The idea of the Turing test brought the concept of machine intelligence into an experimental framework and laid the groundwork for subsequent academic debates. Hardware revolution, the transistor. The invention of transistor by William Shockley and his team fundamentally changed computing power and energy efficiency. Smaller, faster, and more reliable electronics made the practical implementation and complex algorithms and neural networks possible. 1956. Dartmouth, the official beginning. The Dartmouth Conference led to the term artificial intelligence being used in focused scientific events for the first time. The meeting defined the initial research lines for symbolic AI and problem solving approaches. Early AI research centered around symbolic logic, search algorithms, and rule based systems. The era tested the theoretical limits of computation while also laying by foundation or convergence of engineering mathematics. What is AI? Defining intelligence in machine. Artificial Artificial intelligence is the science of developing systems that can perform tasks requiring human intelligence. These tasks include areas such as learning, reasoning, language understanding, perception planning, and creative production. Main branches: machine learning, learning patterns from data; neural networks, multi-layer representation learning; natural language processing, language understanding and generation; computer vision, deriving meaning from visual data. For example, we have GPT-4 model. Large language models like GPT-4 learn linguistic patterns through billions of parameters. They can generate text, summarize, and write code. These models have the ability to maintain context, produce creative content, and adapt to a wide range of tasks. Technically, AI is the capacity of algorithms to generalize from data. In practice, it requires a broad ecosystem of sensors, data pipelines, model architectures, and evolution metrics. The infrastructure is critical for reliable performance and scalability. The rise of machine learning and neural networks. This evolutionary line shows the progression from simple linear classifiers to multiplier deep structures and, more recently, to transformers. Transformer architectures in particular revolutionized language tasks by redefining context management and scalability. Principles of neural networks. Neural networks consist of layered units. Each unit multiplies inputs by weights, processes them with an activation function, and passes the output to the next layer. This structure enables representation learning and the learning of complex relationships. Deep learning and the CPU revolution. The parallel computing power of CPUs reduced the computational barriers to training deep networks. This led to dramatic performance improvements in areas like image and speech recognition. Success example: AlphaGo. AlphaGo is 2016's victory over Lee Sedol was concentrate proof of superhuman decision-making capability in strategic games. The combination of deep learning and search methods heralded a new era. AI in the real world, transforming industries. In finance, algorithmic trading, risk management, and fraud detection have been enhanced by AI. Models detect anomalies in real time to reduce financial losses while also improving performance in areas like credit scoring and customer segmentation. Autonomous vehicles and mobility. Autonomous driving software combines perception, sensor fusion, and planning components. Real-world testing, safety validation, and ethical decision-making are key challenges in this field. Companies are combining simulation with field tests to improve safety. Ethical challenges and risks of AI. Bias and fairness. Errors in data and labeling can lead to the emergence of biased models. These are risks of discrimination in critical applications such as face recognition and hiring. Technical solutions, adversarial debasing, fairness, aware learning, and process diverse data resources, human oversight are required. Privacy and data protection. The collection, processing, and storage of user data raise privacy concerns. Approaches like anonymization, federated learning, and differential privacy offer technical options to mitigate risks. Governance regulation. Regulation should ensure safety without stifling innovation. Principles of transparency, accountability, and human oversight should be cornerstones of regulatory policy. Different countries' approaches and international cooperation are important. Ethical debates also cover workforce transformation and the social impacts of automation. Areas such as weaponized AI, multi-stakeholder dialogue, technical standards, and robust testing processes play a critical role in mitigating these risks. Generative AI, creating content and code. Music creative content. AI offers new production tools in music composition and voice synthesis. By expanding creative workflows and enabling new forms of expression, these technologies should be regulated to align with copyright, licensing, and ethical usage practices. Code and developer tools. Models like OpenAI, Codex, and GitHub Copilot provide suggestions to software developers, speed up repetitive tasks, and shorten prototyping time. However, limitations such as code quality, security vulnerabilities, and copyright concerns must be carefully managed. Art and media. Tools like Midjourney and DALL-E generate images from text, enabling rapid prototyping in film, advertising, and design industries. Legal debates about copyright and the value of creative labor continue. Investment and startup activity saw a major increase in generative AI startups between 2022 and 2024. Sustainable business models, human in the loop designs, and ethical usage policies will provide competitive advantages in this space. The scaling hypothesis and future prospects. This scaling hypothesis suggests that larger models provide better generalization and capabilities. However, constants like computational cost, data quality, and energy consumption call the sustainability of growth into question. In the future, efficient architectures, sparsity techniques, and multimodal models are likely to take the lead. AI as a new digital species, a vision for humanity. Alignment and values. Ethical guidelines, evaluation frameworks, and normal discussion are necessary to ensure AI systems align with human values. Otherwise, unpredictable societal consequences may emerge. Collaboration and augmentation. AI can complement human capabilities, accelerating scientific discovery and expanding creativity. Human AI teamwork brings richer solutions to problems. Global governance. Informational cooperation and mutual standards are important to manage macro-level risks. Technology transfer, equitable access, and responsible deployment policies affect global welfare. Mustafa Suleyman's use of the new digital species metaphor invites consideration of possibility that AI may enter a symbolic or competitive relationship with human society. This metaphor emphasizes the importance of ethical, political, and economic dependencies. Conclusion. Embracing the AI revolution developed rapidly from past to present, from theoretical debates to today's large-scale deep models. These are multi-layered challenges and opportunities both technically and ethically. For reasonable innovation, build multidisciplinary teams, integrate ethics and safety processes, and implement transparency and accountability mechanisms. Support societal adaptation through education and skills transformation. Artificial intelligence is not just a technology, it's humanity's next great chapter. This sentence reminds us that AI should be considered within a social, cultural, and ethical framework beyond technical achievements. The future will be shaped by careful governance, technical excellence, and inclusive policy decisions. Integrating AI in human-centered, fair, and sustainable way should be a primary task for both organizations and societies. Thank you for listening to me. See you in the next video.